So dry type transformer is basically a voltage changing device. So very much the same as an oil type transformer, except for the absence of oil. So used in any electrical application, in any sector. The main difference being that oil-filled transformers use oil as an insulation medium, as well as a cooling medium, whereas a dry type transformer uses only air for insulation and for cooling. So generally speaking, dry type transformers can be used indoor or outdoor, and typically in the past the indoor application made more sense from a perspective of being closer to the load, so easier installation, and generally speaking they are better suited for indoor applications. Due to the advancement of technology over the last number of years, there are times and applications where outdoor installation is the only option, and the design around enclosures and efficiency around cooling of these transformers have become easy for you to be able to do that outside if you understand what you're doing. So you have to define what the harsh conditions are. So generally speaking, in mining applications we have a large amount of dust and a large amount of water often. Dry type transformers are, the medium voltage winding is completely cast in resin, so that really is a good design for ingress and for pollution. So the transformer design itself lends itself to those types of applications as long as they are well protected in the correct IP rated enclosures. So it's critically important because the ability to keep water and dust out, which is what the ingress protection measures, is the amount of dust and the amount of water that an enclosure can protect against. So it's very important that you understand the environment where the transformer is going. So if you have a very high level of dust, you need to be able to design an enclosure that effectively keeps all dust out, but at the same time that you're able to cool the transformer adequately. So local mining conditions and African conditions really are characterized by high ambient temperatures, and then the balance of conditions are similar to anywhere else in the world, very dusty, very wet. So from our perspective, we understand also in the South African context that we have power challenges. So one of the major aspects to our design would be to ensure that the transformer can withstand a volatile power supply, and then thereafter is just to use all of our experience in terms of our standard designs for very dusty, very harsh conditions, and we design our transformers specifically for the conditions that they're going into, and also the enclosure that will house the transformer needs to be specifically designed for that. So we've installed dry type transformers in all over Africa, and really for a host of different commodities. So in South Africa, across the spectrum, gold mining, coal mining, platinum, diamond mines, and then throughout Africa, you know, so West Africa, we've worked in Sierra Leone, we've worked in Ghana, we have projects in Central Africa, DRC, Zambia, and then also East Africa, you know, Mozambique, Tanzania, Kenya. We have a large footprint of transformers for a host of different environments. So the African continent, very much ambient temperatures high. We've also done work in mines with very low ambient temperatures. So previously we've done a gold mine, we've supplied transformers to a gold mine in Kyrgyzstan, which the ambient temperature is minus 40 degrees, and this is an outdoor transformer. So we've got a complete range of products and design protocol for really any conditions and any mining conditions.